All right. Hi. How are we?
Good.
Good? Cool. I'm glad.
All
Uh,
right. Introductions.
introductions.
Hi, I'm Nick. I'm a mentor for Team 6421.
I'm Allison. I'm also a mentor for 6421.
All right. So today we're going to be talking to you about some prototyping strategies, some stuff that hopefully helps you uh, starting right now or in
Like 2
2 hours,
hours.
15 minutes. All right. So what is a prototype? So a prototype is anything that you are using to help you create your final design of your robot. So we'll go through all the different phases of what prototypes are and what the uses are. Um, why do we make prototypes? So the big thing that I want you to get out of this is that prototyping is a tool in your tool belt to be using. So if you find that any particular part of prototyping is not working for you, is not doing the right thing, then you should be moving on. If you're trying to put in a nail and you're using a wrench, you're using the wrong tool. So you should always be using the right, yeah, whatever.
Okay.
Weird analogy, but whatever. You want to use the tools that are most effective for you at what you're trying to do at that time. So take that as you will from this presentation. Um,
Hang on. Can you go back a slide for a
yep.
sec? So, like, as Nick was trying to get at, prototyping is a tool to help you meet your goals. And we're going to go into that a bit more later. It's not meant to be like, you get the game and you're like, all right, I'm going to build my final robot right now. Prototyping is a tool that helps you test out ideas, make sure that they're feasible, that you can build them, that you can program them in a quick amount of time with maybe not your final materials to help you realize your end goals as a team.
Yep.
Now you may proceed.
Okay. So there are a bunch of different phases of prototypes that often get lost and lumped together. So we're going to go through each one of these individually. So concept, optimization, single system, integrated, and prototype robot. So you want to start us off?
Sure. So concept prototype. This is your quick to build, minimal CAD. It's not easy adjustable. It's your, does this idea that we have in our head even like kind of work at
Yeah.
all? It's kind of the, is this idea worth pursuing? Or in layman's terms, it's the stupid check. Like, hey, we have this concept. Do we feel comfortable about it as an idea, or do we want to just test it quick and move on?
Yeah. This is where CAD may not be computer aided design, it may be cardboard aided design. Whatever helps you do things quickly.
Mhm.
Next is your optimization prototype. So you've proven that your concepts can work, should be able to work. So now what you're doing is trying to figure out what are the dimensions that you need to actually make it work on your system. So if you're doing an intake, it's okay, where are the rollers? How far apart do they need to be? If you're on a shooter, it's how much compression, what wheel diameters can we get away with? What speeds should we be shooting these balls at to reach what we're trying to do with the robot?
Yeah.
So these are designed to be easily adjustable, easily tunable, so you can get those dimensions quickly without having to completely disassemble, rebuild, and put stuff back together.
Right. And something with this especially, so like there are some things that First has reused year after year after year, like shooting a ball has been used like every other year for a while now. So you don't really need to concept test most of the time. Does a wheel make a ball go in the air? So sometimes you can skip stages and just go right to optimization.
Yep, yep. That goes back to use the tools, use the right tool at the right time.
Okay.
Single system prototype. So this is, I've done my optimization, I know what my dimensions are, and then you build a full build of your system just on its own to see if it works. So this may not be your final iteration, but this um, tells you that everything that you've done is going to work. The motors are going to work. If you have pneumatics on there, that they're going to extend and retract to the right locations. Um, it doesn't have to be out of the right materials. It could still be out of some of those cheaper materials as long as you're being somewhat high fidelity to your final product in your dimensions, at least what you think is going to work at that time.
Then the next level up from this is an integrated prototype. So this is when you have multiple systems all prototyped together on a robot. And this is testing how two mechanisms work together. So for example, if you have picked up a ball off the ground, maybe you want to also test, can I get that ball to a shooter? So you'd want to test that ball path as well. Or in this one, we had a spindexer here for these little yellow balls. So that spun them into the shooter. and we needed to make sure that relationship, like these could actually physically get into a shooter through this mechanism.
Yeah.
So those are some applications for integrated prototyping.
Yeah. Last step is the prototype robot. So that is you've prototyped all your stuff, you've kind of done all your single systems, all your integrated systems. Now you're building a full robot, probably still not out of your final materials, but just to see how the whole system works together with a real control system, real motors, real code, all the works. But it's probably not what you're bringing to competition. Now, this is a little bit of a higher level of prototype.
Right. So we're just introducing the different levels of prototyping. Not every team's going to do all of them. We don't do all of them.
Yeah.
Some of it's game specific. Some of it's what you want to do specific. And some of these, like, we're probably never going to do this, but it is something you can do if you so want.
Yeah. So I do want to talk about this example a little
Yeah.
bit more. So what we have here is, so this is Hilltopper's robot from 2022. So this is their prototype robot. So you can see like the shooter panel is made out of MDF. The intake was out of a brittle material, but it still allowed them to test at home, test all the dimensions, be able to tweak some stuff between their robots. Because if you look between them, they may not look exactly the same, but they have a lot of the same dimensions, a lot of the same features. But this one was really quick to build, and they were able to test stuff. And this one, they still built it quick. But
I believe in this situation, they were working on the prototype robot all the way up to like the week of their first competition. And then they built and assembled their real one for the first time.
Because they knew everything was going to work because they prototyped so hard on this one.
Right. So that's a route.
Yeah.
Yeah. Yeah. So we touched on this a little bit earlier. You don't always need every stage for every prototype. For example, last year, we knew that we generally were going to have an elevator and an arm system to be able to get cubes and cones to the max extension to be able to play the game. And we did that by buying a kit for the elevator and slapping an arm on the end. We knew that an elevator was going to generally work for our purpose. We didn't need to concept test if an elevator was going to work in the first place.
Yep. All right, making prototypes strategically. So first step.
This is today.
This is today, tomorrow, Monday, somewhere in there. Setting your goals. So before you can start prototyping what your robot can be, you need to set what it should be doing. So you should be setting concrete goals for your team of, we want to, if you say we want to be in a limbs this year, we go, you as a team have to say, okay, what does that mean? What is a robot that is in a limbs? What does that robot do? And then set those goals. So that maybe that robot can drive. That robot can, don't forget, that's an important one.
Seriously,
that's the most
it
important
needs
one.
to drive.
Drive. Second, it can pick up game pieces. It can score those X number of game pieces in Y seconds, and it can climb to whatever in some amount of time. Setting those concrete goals at the beginning give you a benchmark for your prototypes to evaluate your prototypes too.
Yeah, and just to stress on this a little harder, it's really easy on kickoff day to go, ooh, shiny new game. We're just going to go build stuff and go have fun. Having goals helps you frame up your expectations and what you need to be making in order to hit those goals. A robot whose goal is to get picked is not going to be building the same robot as someone who's like, we want to be the #1 seed captain.
We want to go to Einstein.
We want to go to Einstein. Those are two very different robots, right?
Yeah.
So it's really, really, really important as a team to understand, okay, we are shooting to be here, and this is the robot goals that we think will help us get there before you start touching anything and building anything.
Yeah, and it can also help you when you're disagreeing later on what avenue you should be going for, that you go back to your goals and say, this is what we agreed on as a team. Let's make sure that we're either sticking to these or reevaluating them to make sure everyone agrees that you should be going more or less depending on what you set before.
Right, because you're going to be making these goals in the first couple of days of season when you've seen this game for a couple of hours, right? As the season progresses, as you get more familiar with it, as you see other teams getting more familiar with it, sometimes your goals, like what your robot needs to do and what you want to do, need to change, or your goals need to change. It's very, very, very important to keep reflecting on what your goals were on day one and understanding, okay, we're still going for this, or do we want to tweak this a little bit based off how things are going? Those are totally okay.
Setting good goals. So we talked about this a little bit, is that everyone's resources are different. So this is one of my favorite examples. So 2022, one of the best climbers in the world, if not the best.
The best climber in
The
the
best
world.
climber in the world was a robot that just jumped off the ground on 15 feet in the air and grabbed onto a bar. 15 feet?
And it was
like that.
loud and it was awesome.
Now this is what we'll call the best, but that was the best for them. That may not be the best for your team, because something like that is very complicated. It's one of those things that you go, it'd be funny if we jumped, and no one does it, except for this one Canadian.
These guys,
except for these Canadians. So it's good to set realistic goals for your resources and knowledge and the people on your team. The best solution is not the only solution, and it can still get you to where you want to be.
There's no one solution to a problem in FIRST robotics. If it was, that would be kind of boring.
Yes.
So there's always like a lot of different routes to get there. Because I would have no idea how in the heck to build a robot that jumps 15 feet in the air, but I do know how to make a robot that can climb up bars. So
Yep.
that is where our resources are.
Yep.
And it still does the same exact thing.
All right. Before you're doing your prototypes, also do your research. So I think today, I think they already started, there's a history of FRC games. Or no, that's the next two sessions, right? Knowing what games are out there and taking the game that we find today and comparing it to previous games and seeing the similarities and looking at robots from those years, that can give you a lot of leg up on where to start with your mechanisms, where to start with your prototypes. Looking at some of those online resources like Robot in 3 Days, there's feels like 200 open alliance threads of
There's
teams
something
building
like that,
stuff.
yeah.
Look at those resources, see what other teams are doing. I think it's on one of these slides somewhere. One of the famous phrases to go by in FRC is steal from the best, invent the rest.
Yeah. We'll get there, yeah.
Yeah. So do your research.
You're jumping slides.
It's okay.
Okay, prototyping process list. As mentioned before, it's really easy to just start building stuff and having a grand old time, but you need to make sure that you're doing this with purpose, with intent, that you're getting something out of it. One of the big things with prototyping is documenting what you did, especially because these are kind of fast and loose and they might not be built to the highest of quality standards. Writing things down is extremely important. So before you start a prototype, some good things to reflect on are, what are we trying to learn by doing this? Do we generally know how we're going to make this thing in the first place? Do we have like a kind of a plan before we get going? Or like a sketch? Sketches are great for this. And how long do we want to spend on this prototype? It can be very easy to get lost in the weeds and just being like working on this prototype, and all of a sudden it's week 3 and you're like, oh shoot, we should probably have like something done by now. So setting like a general time limit is helpful. While you have a prototype, taking pictures, taking video, documenting how it performs and what it does.
We have another slide on the daring that goes in deeper.
Even better. Oh yeah, we have the realistic one. And then after you've messed with your prototype for a bit, did you learn what you needed? Is this going to help with our goals? Do we need to iterate more? Do we feel okay about it? Like, where do we need to go from here for our next stage of prototyping? Or are we good to just move on, optimize, or build a real robot?
Yep.
Fail fast, fail often is one of those big things that we need to keep working on as well.
There are thousands, if not millions, of ways to fail, and there's fewer ways to do it right. So find all the ways that fail quickly so you can get to the way that's right.
Yeah.
What if you like 2 ideas? So it's inevitable. You're gonna have some people on your team that said, we like these weed whackers, and you're gonna say, no, we like the square hole, and then you're gonna argue back and forth. So when you have 2 ideas, if your team is large enough, sometimes you can spend those resources, but a lot of times it's best to just focus on one idea, get down it as far as possible, and if you find out that it doesn't work, then you pivot back to the other one. But the longer that you go down a path of working on 2 prototypes, the more resources you use. So At the concept phase, maybe you still do two, but once you get to concept and then to optimization and then to single system, if you're still at two different prototypes, that's a lot of resources that you've wasted across both of those prototypes to only choose one in the end. How to test. So when you're testing, make sure you're testing realistically.
One of our favorite examples is when you've just built your brand new intake for your robot and you daintily, gently roll a ball at the perfect speed and angle into it, and oh my God, it grabbed it. That's amazing. That's not realistic. That's never going to happen on a field, right? Probably, unless you got a really good human player. Testing realistically is extremely, extremely important, and that means your driver is going to crash into stuff, or other people, or things will crash into you. I don't care if you say they won't, they will. Like
Drive your intake into a wall because your driver is going to drive your intake into a wall at some point. I don't care how good they are. It's going to happen.
Like, make sure that you are driving into what you are trying to pick up. Or if you're on like a furniture dolly, those work really well if you have swerve or old drive bases.
When you're picking up game pieces off the floor, do it on carpet. It doesn't necessarily have to be the official field carpet, but there is a big difference between picking something off the carpet and linoleum floor. There's a big difference there, so make sure you're keeping that in mind when you're testing stuff.
Yeah, that's good.
Okay. What if you don't have the resources to prototype? I touched on this a little bit. So look at some of those resources online. So RI3D, Everybot. I don't have Kitbot on here, but
oh yeah, we need to add that Kitbot that you're getting. Yeah.
Open Alliance. There are, like I said, there are so many teams that are going to be sharing their entire process, more or less, of everything that they're doing, all the prototypes that they're doing. One team that I will throw out there is 4481. Is that right? Rembrandt's?
Yes, I think so.
Is that the right number? I think.
It's close. I don't know.
Rembrandt's has a lot of awesome videos.
They put out hundreds of like 10-second clips of all of their prototypes. They're awesome. Look at those. You can learn a lot from those. This was the slide for steal from the best, invent the rest. There are thousands of teams doing the same exact thing as you. No need to reinvent the wheel as much as you can. All right.
Speed round.
Speed round. Got about 5 minutes.
We're actually doing pretty good on time.
We do.
All right, speed round.
Okay, so we talked about theory for a while, so this is some practical stuff. So prototype with materials that are cheap and available to your team. Use what you have around. For your prototyping, like I said, cardboard, wood,
foam,
like that pink insulating foam you can get from the hardware stores. It's cheap, it's easy to cut, it's sturdy. You can do a lot with that. Use the cheap crap you have around. It doesn't need to be good.
Prototyping is not the engineering excellence award. Make it work fast. This is my favorite picture in this presentation. I'm going to waste time on it because we had a hex shaft here that was rotating that we wanted to stop rotating. And so we zip tied a wrench to the frame so that it would stop rotating. Your prototypes don't got to be pretty. They just got to work.
Yep. Again, online resources. So there's a lot of stuff out there that can help you with your prototyping and make it quicker. So we use these quick clamping
3D
printed blocks, and these are called hype blocks. So just things that are you can easily mount and attach tubes and motors to tubes. There's a bunch of other resources out there. There was a quick adjust intake. I wasn't able to get a picture for it that someone made recently.
We have links in the slide deck that we'll share in like 5 minutes. Yes. So bear with us.
Yeah. But this stuff is, you can make an intake that works. I'm sure that took them all of 5 minutes.
Well, probably enough. Keep going.
Doesn't take long. Key takeaways. So first one, prototyping is a tool. Make sure you're using the tool appropriately and when it works for you.
Setting goals and revisiting them. Don't just make all your decisions for your year on day one. Think about it and reflect on it often.
Yep. Documentation. I think that's one of the things that most teams struggle with the most. Document everything. You don't want to be getting to second or third time you built a robot and go, why did we make this dimension 5 inches? You want to be able to go back to your documentation from the first week of build season and see, why did we do this? What was the reason for this? It helps further down.
Fail fast, fail often. There's a million ways to fail and a lot more ways to work. But if you get through the things that don't work, you find the things that do.
Yeah. Steal from the best, invent the rest. Use all the resources that are out there. Don't feel ashamed that your thing's not unique. It doesn't need to be to fit your goals. If your goals are to be, then that's your choice. But that's and last one, practice, practice, practice. So it's a little late at this point,
You can
but
get one in really quick.
yeah, the more you practice your prototyping, the quicker you get at it, the better your prototypes are going to be.
Yeah. We'll come back to that slide in a second, but like we have a whole slide of additional resources here. Documentation for Robot in 3 days for every bot. Oh yeah, you were right. Rembrandt's YouTube channel. Spectrum 3847 has amazing lists of information.
Yeah, one that I will point out, the 125 Nutrons, their 2017 Hopper prototype. This is like a
Case study almost.
It's a huge blog post on all the steps that they went through to prototype and make their final Hopper design, and it is incredibly informative, and it's a good read. It's a good read if you're interested.
Can you go back a slide then?
Yes.
All right. Are there any questions? We had to go through this quickly because we were on short in time, but does anyone have any questions? Comments, concerns, statements of elation? If you want to snipe the slides, feel free to scan this QR up here and save a copy to your Google Drive. If you want to come chat with us, we'll be outside after this presentation. Otherwise, thank you all for listening today. We had a wonderful time. Yeah.